For the next two examples, examples A and example B, we're going to perform a procedure called synthetic division. It's really a shortcut for long division for monic polynomials. What are monic polynomials? Well, monic polynomials are polynomials where the highest degree has a coefficient of 1. So in this case, the monic, it's really a monic binomial. So if this is a shortcut for a monic binomial, we got to make sure the coefficient in front of the x is 1. Over here, this is also a monic binomial. The coefficient must be 1 in order to do this procedure called synthetic division. Without this coefficient of 1, the patterns don't follow. So this is really, really important. We're going to take x plus 5 to be the divisor. So what would the long division look like? Let me remind you that before you did this with x plus 5, and you asked yourselves, how many quantities of x plus 5 go into what? X cubed plus 0x squared minus 21x plus 20. Well, for synthetic division, we're going to do things a little bit differently. Instead, we're going to visualize that the factor would be x minus c. So remember, from the factor theorem, you would go x minus c. So in our case, c is equal to negative 5. We put this negative 5 up here in a little box. So we're going to begin the procedure of synthetic division. Now we're going to take all the coefficients of the polynomial, which is 1, 0x squared, negative 21x, and then 20. So these coefficients acts like placeholders. These coefficients actually act like placeholders. The first thing we're going to do is I'm going to draw a line here. We're going to bring down the 1. We bring down the 1. And we're going to take this 1 and multiply it to negative 5. We get negative 5. Take that negative 5 and place it in the next column. And then we add. If you add that vertically, we get negative 5. And then we multiply again. We take this particular negative 5 and multiply it to this negative 5. We get 25. And where do I put that 25? I put that 25 in the next column. And then we add again. We repeat this procedure until you get to the very, very last column. So what's 4 times negative 5? We get 20. We get negative 20. And then we add. And if your remainder is 0, that's actually your remainder now. If your remainder is 0, then we could actually read the quotient. The quotient is actually 1 degree less than the original polynomial. So this is actually saying x squared minus 5x plus 4. So there's your quotient. Let's summarize what just took place. X cubed minus 21x plus 20 divided by the factor, or divided by the divisor of x plus 5, gets you this, x squared minus 5x plus 4. You get a quotient with 0 remainder. Go ahead and try to do example B on your own. You could pause the video, and when you're ready to check your answer, go ahead and unpause the video and reveal the solution. So if we look at this as x minus c, we're going to see that c is equal to negative 3. We take this negative 3 and put it up in the upper left-hand corner, and now we're going to read the coefficients of the original polynomial. We get 1, we get 0x cubed, we get negative 12, we get negative 7, and then we get a 3. Remember, the first step is to draw a bar and then bring down the 1. And now you just simply multiply and add. Notice we get 2 times negative 3 here, which is negative 6. So when you add this, you get a remainder of negative 3. So how do we write our final division problem? Well, let's write our quotient first. Our quotient is 1 degree less than the original polynomial. There it is. And let's add the remainder over to the divisor. The divisor was x plus 3. You could write it like that as an acceptable answer, or you could write it like this. Either one of these are acceptable. I'm going to circle our final answers. Make sure you show your work as well. I'm going to go ahead and circle the work. The work is very important. You are demonstrating procedures in mathematics.